So we're talking about object-oriented programming, and we've talked about the difference between value types and reference types. And I want to drill down into the details of reference assignment. What happens when we have an assignment statement in which the type of variable is a reference type and in which we're assigning an object to a variable? So we have a relatively simple 21-line program here written in Java. We've got two classes. We've got a very simple bunny class, which just has a name property and an age property, a string and an int variable for those. And then we've got a basic driver class, which has a main method. And inside the main method, we're going to declare a couple of variables, do some instantiation, and then manipulate the properties of those objects, producing an output. And we'll walk through the steps of what happens here mechanically. So we'll set up our stack, our heap memory space, and our console for our output. So the first thing that's going to happen is the bunny class will be created in memory. This becomes the blueprint or the template for instantiating bunny objects in memory. And those are just going to be a string for the name and an int for the age. And then we create our driver class, which contains our main method. And at this point, the operating system is ready to call the main method. Creates, of course, a stack frame for the main method, records the return point, which in this case, the main method is being called by the operating system. So when main returns, will return to the operating system. Then the local variables are created in the stack. In this case, we've got two variables of type bunny, one named Flopsy and one named Cottontail. And then we can start to execute the lines of instructions for the main method. When this variable is declared, it's initialized by default to null. Same thing for the variable Cottontail. Remember that a reference type variable is always going to store either a reference to an object of that type, or it stores the special reference null, meaning it doesn't refer to an object at this time. So line 11 here, we're going to instantiate a bunny object, and that's what the keyword new does. And so this uses the bunny class as a cookie cutter or a template or a blueprint to stamp out a bunny object in memory that has its own name and its own age. And these are initialized to the values that are defined in the bunny class. And the next thing that happens is this instantiation expression, new bunny, itself evaluates to a reference to the object that was instantiated. So that when we do the assignment, we're going to assign that reference to this variable. And so this local variable Flopsy is now a reference to this bunny object that we instantiated in memory. It's important to note that the only way to instantiate a bunny object in memory is to use the keyword new. So now on line 12, we're going to use this local variable Flopsy, which is a reference to this bunny object, to manipulate that object. So when we refer to the variable, this is the local variable Flopsy, whose value is a reference to this actual bunny object. And if we use the dot operator on that, that gets us to that object. It dereferences that variable. So that variable Flopsy is a reference to this bunny object, and the dot operator causes that reference to be dereferenced, and that evaluates to the object. And now if we say Flopsy dot name, well, the reference Flopsy refers to this bunny object, and we're referring to its name. And here we're going to store the value Flopsy. And so that value gets stored there. And now we're going to do something very similar on line 12. We're going to use this local variable Flopsy, which again is a reference to this bunny object. When we use the dot operator on that variable, we get the object, and then we can refer to one of the object's properties or methods, in this case the age property, and we're going to assign an 8 there. And so an 8 gets stored in this bunny object's age variable. Now in line 15, something interesting is going to happen. It's a simple assignment statement assigning to Cottontail Flopsy. And this might be a little surprising, but it really works the same way as if we were assigning one int to another int. So if I have an int A and an int B, and A currently has the value 3, and I say B equals A, then I'm also storing a 3 in B. And in that same sense, since I'm assigning to Cottontail the same thing that's stored in Flopsy, then Cottontail is just going to be a copy of the value stored in Flopsy. The value stored in Flopsy is a reference to this bunny object, and a copy of that will also be a reference to this bunny object. And so now we have two variables that both refer to the same object. This may seem strange, but it comes in very handy often. This is a mechanism that we can use to pass an object as an argument to another function. And now we're going to use the Cottontail variable, and we're going to assign a value to the name of the bunny object that this variable refers to. And in this case, Cottontail is a reference to this bunny that we instantiated on line 11. When we dot off of that variable, we get this bunny object, and then we can access its name, and we can store the text Cottontail there, replacing the text Flopsy. And then we can do the same kind of thing on line 17. Cottontail is a variable that is a reference to a bunny object. When we dot off of that variable, we get that bunny object, and we can access a property, in this case the age of that bunny object, and assign a value there. And so now when we go to print out flopsy.name, we're using the Flopsy variable, which is just another variable that stores a reference to this one and only bunny object, the only bunny object we've instantiated. We dot off of it to get a hold of that bunny object, and then we can access its name, which is Cottontail, and this, unsurprisingly, now that we know, prints out Cottontail. So a common mistake is to believe that an assignment of a reference type object to another variable is going to create a copy of that object. It's not. It's going to create a copy of the reference, and now you'll have two references to the same object. The only way to have two objects is to instantiate two objects, and the only way to instantiate an object is with the keyword new. So in this program where we only see the keyword new once, we know we're only going to have one bunny, regardless of how many variables and assignments we do. So don't let this trip you up. Once the program finishes and main concludes, the stack frame is cleaned up, and we return to the operating system. The operating system cleans up memory, and the program terminates.